All right, I'll try and keep it a quick video today. Just a lot of review of things you've been learning and practicing since 7th, 8th, 9th grade. And we'll get just a little bit more complex this year. So we're talking about solving equations. And really solving an equation that contains a variable. All that means is that you're finding all the values of the variable that make the equation true. So for example, if I say x plus 4 equals 7, solving this equation for x means figuring out what makes this true when I plug it in, which x equals 3, because 3 plus 4 equals 7. So that's called a solution of the equation. So to find a solution, we isolate the variable on one side of the equation using inverse operations. And this is something you've been doing since 7th grade. And that just means when I have x plus 4 equals 7, I'm isolating the variable, meaning I'm getting x by itself by working using inverse operations to get rid of everything else. I want to move this plus 4 to the other side so that x is on its own. So I minus 4 on both sides, which gives me x equals 3. Okay, so here's an example. And there are millions of examples that we could go through. And there's really 3 steps that we're going to focus on that apply to you don't always have to use every step in every problem, but there are 3 ideas that you need to keep in mind when you're solving these problems. So step 1 says to simplify the equation so that none of the variables you're solving for are inside parentheses. So look at this example right here. 3 times 2x minus 1. The 2x is inside parentheses. This 3x is inside parentheses. That's a problem. So we need to simplify the equation and make that go away. So we're going to distribute in this case. So 3 times 2x minus 1 minus 2 times 3x plus 4 equals 11x. So I've got to distribute this 3 to the 2x and the negative 1. So 3 times 2x is 6x. 3 times 1 is negative 3. And then I have to distribute the negative 2. Please don't forget that negative, to the 3x and the 4. So negative 2 times 3x is negative 6x, and negative 2 times 4 is negative 8. And that all still equals 11x. And then we combine like terms when possible. 6x minus 6x, that's nice because 6 minus 6 is actually 0. So the x's go away on this side. And negative 3 minus 8, when I combine those, I get negative 11 equals 11x. So in this case, we had variables inside parentheses. We had to get rid of them. Okay, now from here, negative 11 equals 11x. You just solve for x by getting it by itself. So I would divide by 11, and get negative 1 is equal to x. The other step that we need to keep in mind, sometimes after you distribute, after you get rid of the parentheses, we have to use inverse operations to move all of the terms with the variable you're solving for to the same side. So for example, let's say I have 2x plus 5 is equal to negative 4x minus 7. Now, I don't like having an x on both sides. So I want to get my x's together on one side of the equation. Usually what I try to do is I try to keep my x's positive. So if I move my 2x's over here to the other side, I'm going to have a bunch of negative x's. So I'm going to add 4x. I'm going to move this 4x to the left by adding it to the left. So it goes away on this side. Now I've got 2x's plus 4x's. So I have 6x plus 5 on the left, and that equals negative 7 on the right. Okay. From here, this says step 2. Change that to a 3 for me. Remember, just isolating the variable, you follow the order of operations backwards. So we're going to continue with this problem for our example right here. So 6x plus 5 equals negative 7. Right now, I'm doing more than one thing to x. I'm timesing by 6 and I'm adding 5. And normally, order of operations tells me PEMDAS, right? That I do parentheses, exponents, then multiply and divide, then I add and subtract. But remember when we're isolating the variable, we do them backwards, okay? We're going to add it. We're going to get rid of adding and subtracting first. Then we're going to get rid of multiplying and dividing. So over here, I have a 6 to get rid of and a plus 5. I'm going to get rid of the plus 5 first because I do order of operations backwards. So I'm going to minus 5 from both sides, and I get 6x equals negative 12. Now I want to get rid of this 6 by dividing by 6. So x equals negative 2. That would be my solution. Okay. So step 1 on any sort of solving equation problem, solving for a variable, if there's x's inside parentheses, move them to the outside. Okay. Distribute and simplify as much as you can. Then if there's x's on both sides, move all of them to the same side, or I guess any variable, it might not be an x, move the variables to the same side. And remember, when you're isolating, when you're going through those inverse operations, you're doing order of operations backwards. So a couple examples, and then I'm going to have you try a few. 2 minus 3 times x plus 4 equals 8. I have an x inside parentheses, so I want to distribute the negative 3. So this 2 is still there. And then actually, let me give myself a little bit more room. The 2 is still there. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And that still equals 8. Combine like terms, 2 and negative 12 is negative 10 minus 3x equals 8. Now, I only have x's on the left. So I'm going to isolate my x. I'm going to move everything else to the other side so that x is by itself. And I need to do that in the backward order of operations. So I need to get rid of adding and subtracting first. So this minus 10, I'm going to move first by adding 10. So negative 3x equals 18. Then I'm going to divide by negative 3. So x is equal to negative 6. All right. The second example, 12 minus 3 times 2w plus, let's put a 1 right there. Do I want a 1? No, let's make that a 9. Sorry, let's make that a plus 9. Equals 7w minus 3 times 7 plus w. So let's distribute first to get rid of all of these parentheses. So 12, I'm going to distribute the negative 3 to the 2w and the 9. Negative 3 times 2w is negative 6w. Negative 3 times 9 is going to be negative 27. And that equals 7w. And I've got to distribute this negative 3 also. Negative 3 times 7 is negative 21. Negative 3 times w is negative 3w. Now I want to combine like terms. 12 and negative 27. That makes negative 15. And I've got a negative 6w out here. And that equals 7w minus 3w. That's 4w's minus 21. Step 2 was to make sure all the variables that we want are on the same side. So I have w's on the left and the right. To keep them positive, I'm going to add 6w's to both sides. I'm going to move these negative w's to the other side. So those go away. So negative 15 equals 4w plus 6w, 10w minus 21. Now, in order to get rid of everything else on this side, inverse operations, starting backwards from my order. So I'm going to add 21 to both sides first. So when I add 21, this becomes 6 equals 10w. Now to get rid of the 10, I'm going to divide by 10, and I'm going to divide by 10. So w is equal to 6 divided by 10, which is 3/5, which is a great answer. Okay. Go ahead, pause the video. I want you to try these two problems on your own, see if you can figure them out, and then start the video and I'll walk you through. Now, since you've already done this problem, I'm going to go ahead and go quickly. Distribute the negative 2. 13 minus 2x minus 14 equals negative 9. Combine like terms, 13 minus 14 is negative 1 minus 2x equals negative 9. I want to get the x's by itself, so I have to get rid of the minus 1 first by adding 1. So negative 2x equals negative 8. And to get rid of negative 2, I divide by negative 2. divide by negative 2, x equals 4. Okay, on the second one, I've got a lot of distribution to do. 7 distributed to the a plus 1, so 7a plus 7 minus 3a equals 5 plus 4 distributed to 2a minus 1. 4 times 2a is 8a. 4 times negative 1 is negative 4. So combining like terms, 7a minus 3a is 4a's plus 7. 5 minus 4 is 1 plus 8a. Now I want to get all of my a's on the same side. So I'm going to subtract 4a over here and subtract 4a. And this becomes 7 equals 1 plus 4a. Minus 1 from both sides. 6 equals 4a. Divide by 4. Divide by 4. So a is equal to 6/4, which equals 3/2. That would be your final answer. Okay. Most of this you've seen before. For some of you, this part will be a little bit more new. What happens when we have more than one variable? What if I have 6k minus 2z equals 12, and it wants me to solve for k? What that means is I'm getting k by itself, and what I'm going to do, step 1 says we still isolate the variable. I still get k by itself. I'm going to treat all the other variables, this z, I'm just going to treat it like it's any other number when I'm isolating my k. So 6k minus 2z equals 12. In order to get the k by itself, I need to do order of operations backwards. So I can't get rid of the 6. I've got to get rid of the minus 2z first. So I'm going to add 2z to both sides. So 6k equals 12 plus 2z. And then to get rid of the 6, I divide by 6. And here's one place you need to be really careful. I'm dividing this entire side by 6. So on the right-hand side, I also have to divide everything by 6. So I usually put a fraction bar there to remember, don't just divide one thing, divide everything. So k is equal to 12 plus 2z divided by 6. This is a pretty good answer. If it wants you to simplify it more, dividing all of this by 6 means I have to divide both parts by 6. So 12 divided by 6 would be 2. 2z divided by 6 would be 1/3 z. So you have two possible answers, just depending on how simplified it wants the problem to be, okay? Then I added a little note at the bottom of your sheet here. If a problem asks you to solve for x in terms of k, all that means is you're still solving for x. You're still getting x equals something. But what the in terms of k means is that on the other side, there's going to be a k somehow. So solving for x still means get x by itself. The in terms just means that part of your answer is going to have a k in it. So there's a little example here we'll do really quick. K equals c plus 273. What is c in terms of k? So I want to get c by itself. So in order to do that, I need to move this 273. So I'm going to minus 273 and minus 273 from this side. Whoops, 273. So k minus 273 equals c. So I answered the question. C in terms of k just means there's a k on that side. All right. So a couple examples. Solve each of these for k. 4k plus h equals negative 2k minus 14. I got to get my k's together first of all. So let's add 2k to both sides. So 6k plus h equals negative 14. To get rid of everything over here, I've got a 6 and a plus h. I've got a minus h first. So 6k equals negative 14 minus h. Divide by 6. Remember to divide this entire side by 6. So k equals negative 14 minus h divided by 6. That would be your final answer. Again, if it wants it simplified more, you could divide both of these by 6. and end up with -7/3 minus h over 6. That would be an answer as well, but I like this one better. Okay, go ahead, pause the video and try these two, see what you can do. All right, on this one, r minus 2k equals 15. I'm getting k by itself, so I've got a minus r. So -2k equals 15 minus r. To get rid of the -2 being multiplied by k, I'm going to divide by -2. Divide by -2. So k equals 15 minus r all over -2. Don't forget that fraction bar there, because you have to divide everything by -2. And I'm okay with that answer. If it wants it simplified more, you could have -15 over 2 plus r over 2. But I like this one better. It looks cleaner to me. Now on this one, we're getting k by itself, and I'm multiplying k by pi, and I'm multiplying it by r to the 4th, and I'm multiplying it by 1/9. So to get rid of those, I usually would divide all of them. But I don't like dividing by fractions when I'm solving equations. There's another way to undo. If I'm doing 1/9 times x, there's another way to get rid of the 1/9. And instead of dividing by 1/9, we're not going to do it that way. We're going to times by the opposite, 9 over 1. Because when I do that, this becomes 9 over 9, which becomes 1, and that gets rid of the fraction. So on my problem right here, what I'm going to do, instead of dividing by 1/9 to get rid of the 1/9, I'm going to times this side by 9, and I'm going to times this side by 9, because then that goes away, and I have 9v equals pi r to the 4th times k. Now to get rid of timesing by pi and timesing by r to the 4th, I just have to divide by pi and r to the 4th. So divide by pi r to the 4th. So 9v divided by pi r to the 4th equals k. So you're treating everything else like it's a number, and just moving it to the other side. Okay. Every once in a while, you're going to have to factor out a variable that you're solving for to get it alone. So just in this example, this isn't probably going to be on your test, but it is going to be on the homework. And it's one of those questions that shows up on the ACT a lot. So it wants me to solve for x. The problem is, instead of having 2x plus 3x equals c, I have ax plus bx equals c. And that's a little bit harder to do because we don't know what a and b are. If this were my problem, I would add 2 and 3 together. So I would actually do 2 plus 3, and whatever that answer is, that would be in front of my x, and I would get a c on the other side. So we're going to do the same thing. Ax plus bx, well, that's just a plus b x's equals c. And now to get x alone, I have an a plus b that's technically being multiplied by x. So I'm going to divide by a plus b and divide by a plus b. So x is equal to c divided by a plus b. You will see that on the homework, and you will probably see that at some point on an ACT or college prep test. All right. Okay, last thing. We're going to actually go over this next time in class, and that's using equations to solve word problems. A lot of times you get a story problem like this one. The first stage of a rocket burns 28 seconds longer than the second stage. If the total burning time for both stages is 152, how long does each stage burn? So really, we're just going to write an equation that represents the story problem. So it tells me, I usually look at the end first. If the total burning time for both stages, so stage 1 plus stage 2, if I add those together, the total time is equal to 152. But it wants to know, how long does each stage burn? So it wants to know, how long is stage 1 and how long is stage 2. So let's look at the rest of the problem. The first stage of a rocket burns 28 seconds longer than the second stage. So this stage right here burns 28 seconds longer, so plus 28, than the second stage, which is really nice because that gives me an option instead of having these two variables, because I don't know what stage 1 and stage 2 are, and I can't solve for either of them because there's two of them. I can solve for stage 1. I can say stage 1 equals 152 minus stage 2, but that doesn't help me get a number. But if I change my stage 1, which happens to be 28 seconds longer than stage 2, I'm going to plug that in for stage 1. So stage 2 plus 28 seconds plus stage 2 equals 152. So I have two stage 2s. So two stage 2s plus 28 equals 152. So minus 28 minus 28. So two stage 2s, that's a mouthful. Two stage 2s, 152 minus 28. 152 minus 20 is 132. Minus another 8 is going to be 124. So 20, or sorry, not 25. Two stage 2s equals 124. Divide by 2, divide by 2. Stage 2 is equal to 124 divided by 2 is 62 seconds. So stage 2 is 62 seconds. And stage 1 is 28 seconds longer. So 62 plus 28 is 90. So 90 plus 62 equals 152. So stage 1, 90. Stage 2, 62. Now there are a million story problems out there, and they're all different. They all use different formulas, different variables, different numbers. First things first, write an equation that represents the problem right here. And then start assigning variables to find what it is you're looking for, to find the unknown, okay? On your homework, we're doing homework, excuse me, homework 15. Number 1 is a story problem. I think it's the only story problem. Try it on your own. If you struggle, when you come to class on Monday, we'll do what we can to help you through it. Okay, we'll go over it as a class. So homework 15, it's due on Monday. And come prepared to talk about that story problem. All right, good luck.